In this video, we're going to look at how to plot a smooth function in views. In particular, looking at how to plot a Gaussian distribution or a normal curve or a bell curve, it goes by several names, using the data from problem 3.7 in the book. Here, the important part for the distribution is going to be the mean and the standard deviation, which is given to us in the problem as 852 millimeters and 82 millimeters respectively. What we need to do then is input this into an equation for the the Gaussian distribution, which can be found on Wikipedia or in your book. Here we've navigated to the Wikipedia page for the normal distribution, and if we look over here at the graphs, we can see the standard bell curve that we're used to seeing. If we scroll down a little bit, this is the cumulative distribution function, which we would get from integrating the Gaussian distribution, or that bell curve that we saw. And so if we look down farther, we see the equations associated with this, and in particular, what we want is a probability distribution function that is given in this equation here. What we need in this function that is a variable is the standard deviation, shown here as sigma squared, and also in this exponent as sigma squared, and then also the mean value shown as mu here. We can't just copy this equation and put it into views. We have to put it into a form that views will recognize, and I will show that to you when we navigate to views. But first I'll also show it to you written out here in Word on the left. There are a few things to note about this. First, these are the same two equations. The important things to note is that exponents, for instance, the squared term here, are represented in views as a double asterisk. We use double asterisks for the exponents and single asterisks to indicate multiplication. I've also put in values just for now of the standard deviation, S, and the here and here, and then a variable for the mean, which I'm calling M. We can make substitutions into this equation based off of the problem, and so to do that, we'll just copy the same equation and then edit this equation in order to replace the variable for S, or standard deviation, with the standard deviation given in the problem, which was 82 millimeters. We'll replace the other standard deviation with 82 millimeters, and then the mean finally with the mean for the problem, which was 852 milliliters. We'll reserve x here as the variable on which this depends, as that will be recognized by views as us plotting a y value versus this x value here. At this point, we're ready to import this into views in order to plot a curve. So I'll just go ahead and select and copy this equation and move into views. This is now the standard look of views that we're used to when we first open it up. Again, we have a page, but we don't have anything yet ready to plot. As remember from last time, what we need to do is insert axes. And once we've inserted axes, the next thing that we're going to do is insert a smooth function, which we accomplish by pressing the button that I just circled in red. So step one, insert a set of axes. Now that we've done that, you see these buttons have lit up, and then we're going to select this one here, which says plot a function. Now we have a new properties window associated with plotting this function, and below that we have the place to input the actual function. So all I'm going to do is select that function, which right now is just x, and actually before I input the function, let's just look at the line that appeared in the plot. We'll see that I have this nice straight line in which y equals x, and so it has actually already plotted the function that is the default, which is simply x. If we put in the function that we copied with our answers, or the input values, now we're ready to see the normal curve. I have to press the enter button, and you'll see the red line in the plot change shape when I do. You could have seen it changed slightly. What you'll notice is it still looks like a straight line. The reason for this is that the x-axis is not scaled properly to allow us to see this. The x-axis is only showing right now 0 to 1, although we know that the mean value, or the value for which y should be a maximum, should be at 852. So we're looking at a much too small area. What we need to do is expand the range of the x-axis. We do that by clicking or selecting the x-axis in the editing pane. So here we go, select the x-axis. Once we do that, we can go down to the properties window and adjust the max and min values, and then input numbers for the min and the max. Since we're going to be centered around the mean, again at 852, what I would think of doing is moving several distribution standard deviations up and below that. And so let's start by looking at something about maybe the minimum being 400 and the maximum being 1200. Now you see that we have something shown in the plot area that does look like a standard Gaussian plot or normal curve. One thing that you might notice if you look at this curve is that it's a bit jaggedy. You can see that up here at the top, where we're changing quickly, there's these sort of discontinuous jumps in the slope. And the reason for this can be seen if we look at the formatting pane for the function. And so we need to select function first in the editing pane, and once I select the function, then over in formatting I can see something about the number of steps involved in this function. This is under the main tab for the formatting of the function. We only have 50 steps, and so that means for the entire function region that is being shown, we're only plotting 50 different segments. That's the reason for it being jagged. If I add a 0, that'll get us to 500, and you can see that when I added a 0, the top section of this curve has smoothed itself out. And so now we have a smooth looking bell curve that is centered at 852 millimeters and also has the standard deviation that we want. What we're going to do now is just add a few more elements to this graph in order to label where the mean is and where the standard deviation values are. To do this, the easiest thing to do is just simply to add another function, which we can accomplish by pressing the function button again. There are other ways to do this, but let's just do it this way one time. Now that I've added a new function, you can see that we've automatically selected function 2. You'll also know that over in the graph pane, we can no longer see that red Gaussian curve. The reason for this is that we have now just recently plotted a function of x equals y, which means that the maximum value that we're seeing here is about 1200. Our normal curve did not have a value that high, and so it's essentially swamped out by the values that we're seeing for this blue curve. That's okay though, we're going to change the curve. I want to put a vertical line at the mean. In order to get a vertical line, I need to have a function that's plotted as the variable y. To do that, I change the variable. Just using this drop-down menu, I will say I want to plot a function as y. It says I can't evaluate x in the main pane now, which is fine. It's hard to plot a function of x when you're telling it the variable is y. We don't even want a variable. We just want a constant value. So I'm going to type in the mean, 852. Before I hit enter, I do want to point out that once this function disappeared, we see this smooth curve again because the y range now is back to 10 to the minus third, is large enough to actually see the total value. So now that I have 852 selected, I'll just press enter, and now we see there is a blue line back in the main pane that runs right through the middle of this standard Gaussian distribution. So now we have a place for the mean. To indicate where the standard deviations lie, let's think about just indicating +1 and -1 standard deviation from the mean. We can calculate those values. +1 standard deviation would give us 934, -1 standard deviation would give us 770. And again, let's just plot a vertical function that gives us a line at those positions. To do it this time, instead of creating a new function and then going through and changing the variable to y, we can save some time by just copying and pasting the function we already have that has y as the variable. So I'll do this just as if I was selecting and copying and pasting text. I go over, select function 2, Control C to copy, Control V to paste. You'll see I now have a new function 3. It also has a function value of 852. Let's put in the value that would move it 1 standard deviation higher, which is 934. Pressing enter gives me a new line that's green, that's 1 standard deviation to the right. To finish this video, I'm just going to repeat this process to make one line 1 standard deviation to the left. I go to function 3, copy, paste. I have a new line that's function 4. I will change the value of this function to be 770. Press enter, and I have a purple line now that is at 1 standard deviation to the left. A few things I want to say about this plot before concluding the video is that every time we have added a new line, the color has automatically changed. These colors aren't great, but at least you do get different colors. We will look at a different time how to adjust these colors, or you can play around with it if you like inside of Views. For now, we've indicated the position of the mean, plus 1 standard deviation, and minus 1 standard deviation. Of course, it might be nice to label what these are, and so in the next video, we'll show how to do that.